This is the information covering climate and different climate zones. And this is an overview of the information that needs to be in your climate booklet. For your climate booklet, you might use the same information, but you will need more details as well as illustrations and specific examples. So starting out, what is climate? And it's easiest, I think, to look at climate if you compare it to weather. Weather is the day-to-day conditions in the atmosphere of precipitation and temperature. Weather is constantly changing and very difficult to predict. It may vary widely in a given region. So, for example, it's sunny and hot today, or it is cold and snowy, or it's hot and sunny in the afternoon, changing to thunderstorms, cooler and windy and raining. Climate, on the other hand, is the average weather of an area over decades or centuries. It also is characterized by precipitation and temperature. So, for example, the climate in Arizona is hot and dry. The climate in Florida is hot and humid. And although climate may change very slowly in a region, climate is generally relatively steady and predictable. Next, we will look at the different factors that affect the precipitation and temperature, since those are the defining factors of climate. There are 4 factors that affect temperature. If you are doing your booklet, you can put them each on a separate page and make illustrations to go with them. The first of the 4 factors that affect temperature is latitude. In areas closer to the equator, the temperature is warmer. This is pretty obvious to most of us. When you look at the Earth, you know from when we talked about seasons, near the equator it is warm. That is because there is more direct sunlight hitting that part of the Earth, and so the temperatures are warmer. Similarly, at the poles, the sun hits at a more oblique angle and does not warm the area as much, so at the poles it is colder. Again, pretty obvious and logical, and so then you could also from there realize that places closer to the equator, even though they're not exactly there, are going to be warmer climates in general, and likewise further north and south, closer to the poles, will be cooler climates. Latitude. All right, the next factor is altitude. And this is something that here in Colorado is something that we are relatively familiar with. Simply when you go higher up in altitude, the temperatures are generally cooler than lower down. So at the same latitude, as you go up into the mountains, it's going to be colder than somewhere down lower. So say in Denver, it's generally going to be warmer than if you are up in Breckenridge. All right, latitude, altitude. The next 2 of the 4 factors are distance from large bodies of water and ocean currents. Distance from large bodies of water affects temperature because water changes temperature very slowly. We've talked about this with land and sea breeze and a number of different other examples. When you look at being near a large body of water, the temperatures are going to be more moderate because the water changes temperature so slowly. The ocean year-round stays at nearly the same temperature. Large bodies of water like lakes will do the same thing. So if you are somewhere like Seattle or any coastal area, New York, either coast, you're going to have weather, you're going to have temperatures that never get extremely cold and never get extremely hot, because the wind coming off the water and the humidity coming off the water are going to cool down the hotter temperatures and warm up the colder temperature, because the ocean is not going to boil, nor is it going to freeze. It's going to stay at that same temperature. So being near large bodies of water will keep the temperature more moderate. Ocean currents. Ocean currents are interesting because they are going to change the expected climate at a given area. So warm or cold currents might make the climate in an area warmer or cooler than you would expect for the latitude and altitude. And above here we see a map of some of the major ocean currents. Warm water currents are red, cold water are blue. And if you look, for instance, at the United States, along the Pacific coast, we have a cold water current coming down. It's called the California current, coming down along the Pacific coast. On the other hand, you look over here on the Atlantic coast, and you have a warm water current coming up here. I believe that's the Gulf Stream. And so if you pick an area at the same latitude, so say pick something over here like Seattle, something over here like, I don't know, New York, New Jersey, you can go to a beach in either place. On the east coast here, it's going to be warmer. The water's going to be warmer, making it a warmer climate as compared to vacationing in Seattle, where it's going to be chilly and not so pleasant at the beach. The latitude is the same because we picked it that way. The altitude is the same. They are both at sea level. You can look across the globe here in this picture and see how that might affect both South America. Europe has different areas, and look and see that there are going to be areas at the same latitude that would have different climates. This is a larger map of the same thing so that you can kind of see those currents. It is from the textbook, page 617. As well as the factors that affect temperature, there are three factors that affect precipitation. They are prevailing winds, seasonal winds, and mountain ranges. And we're going to see that all these things work together to some extent to create climate. Prevailing winds. In the United States, winds generally blow from west to east. We talked about prevailing winds, global winds, quite a bit in class. And so these are just general wind patterns of an area. So winds blowing from west to east, if you also look at mountain ranges or large bodies of water, that is going to affect the climate, or excuse me, the precipitation, because it's going to affect the amount of moisture in the air. Seasonal winds are winds of an area that change with the season, just like the name implies, and some common seasonal winds that you may have heard of are the summer monsoons. A monsoon is a summer wind that generally brings a tremendous amount of rain. In the southwest of the United States, in Arizona, and to some extent in Colorado, we get summer monsoons in July and August. So you get these afternoon storms that generally come up from the Gulf of Mexico with warm, wet air. When it gets up to here, you get afternoon thunderstorms and heavy rains. In Arizona, the rains are more pronounced. And in the textbook, it talks about the monsoon seasons in places like India, which are much more extreme and create huge rainy summers and then drier winters when the wind is blowing from the other direction. So you can check that out. A Chinook is also a seasonal wind, not as much affecting the precipitation, but it's a seasonal wind we have around here in the spring. The Chinook is a warm wind that blows in the spring and melts the snow. Chinook, I believe, comes from a word that means snow eater. So we get those extremely windy days that bring the warmer weather. A seasonal wind, not directly related to precipitation. And then finally, mountain ranges affect precipitation. And this is something we can see very distinctly in Colorado. And so we look at this next slide here. Mountain ranges affecting precipitation. So if you were to take a cross-section of Colorado from the west over here to east over here, we have a number of factors, and the mountains getting in the middle of them to create precipitation. The prevailing winds in Colorado are going to blow from the west to the east, the west wind. So those winds are coming from the west, where you might have such things as warm, wet air from California. As that air comes along, carrying moisture, it's going to run into the mountains. So clouds full of moisture here, moving this direction. They come to the mountains here in western Colorado, Glenwood Springs, and other areas like this. The clouds move up, and that causes the clouds to get cooler. The cooler air holds less moisture. The moisture condenses and eventually falls out as rain. So here on the western slope, they get much more rainfall. And if you've ever driven I-70 out west, you'll notice as you come down out of the mountains, it's very green. There's a lot of Colorado peaches are grown on the western slope, a lot of grapes, many fruits that would not grow where we are here in the Front Range grow very well on the western slope. This is known as the windward side of the mountains. The wind is blowing this way, and this happens anywhere you have a mountain range. On the windward side, you will get more rain. So then continuing up, the clouds go up, even higher altitude, and of course snow. You get lots of snow up in the high country. And then by the time the clouds get over here to our side of the state, the clouds have less moisture. Clouds have less moisture. So they've rained and snowed, and there's not so much here. This is what's called a rain shadow. And just like a shadow gets no light, a rain shadow doesn't get rain. We get some, and as somebody mentioned, we would get more storms if the clouds had a tremendous amount of moisture to start with. So rain shadow here in the Front Range of Colorado. Now, how might we get a nice storm with a ton of moisture in it, lots of rain, lots of snow? We get something called an upslope. And an upslope is a storm that's moving the opposite direction. So it's coming from the east, and oftentimes our upslopes come up from the Gulf of Mexico, so it's warm, wet air, got a lot of moisture in it, comes up, hits the mountains, and goes up and dumps lots of precipitation here on us. And this actually falls in the category with seasonal winds as well, because oftentimes we get these in March. Our best chance for a snow day is a good upslope. We'll get a big, wet spring storm with a lot of moisture falling all at once. So mountain range affects precipitation. And you see there, too, that the mountain range affecting it is tied in with large bodies of water, with prevailing winds, sometimes seasonal winds. So all these things work together to affect temperature and precipitation. Finally, there are 6 major climate zones on the Earth. The textbook on page 626 has a very nice picture of this, which details all of them and shows where each one is located. For your climate booklet, you do need to have information for each of these climate zones, examples specifically of where they occur and such things, pictures. But just to give you an overview of what you need to have on these pages, the first climate zone is tropical rainy, so obviously warm and wet, or hot and humid. And then there's 2 subdivisions of that. There's tropical wet, which is pretty much always humid, more than 6 centimeters of rain a year, and tropical wet and dry, which is always hot, but alternating dry season and rainy season. Then, secondly, we have the dry climate. And this, it doesn't actually say it, but this is actually more the dry in terms of desert, so dry in terms of rainfall. So the dry climates are primarily defined by less than 10 inches of rain per year. And I know most of these rainfall amounts are in centimeters, which is a little bit difficult, but you can convert them. I'm sure you have an iPhone or a calculator that can do the conversion, but basically 2.5 centimeters equals 1 inch. You can do your own conversions to make it more useful for you. The third climate zone, temperate marine, and there are three subdivisions of that. Mediterranean, which imagine the Mediterranean Sea, warm summers and rainy winters. Temperate, the word temperate means an area that has warm and cold times, but it's not extremely hot or extremely cold all the time. So Mediterranean, warm summers, rainy winters. Humid subtropical, so humid and subtropical means below the tropics. Hot summers and cool winters. And then marine west coast, which would happen here on the west coast of the United States, mild winters, cool summers, and moderate rain all year. And so you're going to get that all along California, Oregon, and Washington State. The next three climate zones, temperate continental. And we have some of these in the United States. Humid continental, as it suggests, humid, it has higher rainfall and humid conditions. Continental, so it's within the continent, so southern United States. And subarctic, being below the Arctic, so not as cold as something polar. Subarctic has short, cool summers, long, cold winters. Short, cool summers, long, cold winters. And similarly, the humid continental, hot, humid summers, moderate precipitation year-round. Hot summers, moderate winter, and precipitation. Polar, we're going to have two designations of that. Tundra, always cold, cool summers, and the warmest temperature, it never gets very warm, basically. Always cold. It says never above 10 degrees Celsius. Got to do your conversion there. And ice cap, which is going to be cool short summers, long cold winters, light precipitation, mainly in the summer. So the big difference between these two, this has light precipitation in the summer, and the tundra had moderate precipitation year-round. And then finally, the last designation is highlands. And highlands is simply describing an area of a higher altitude that's generally cooler and wetter than the nearby lowlands. And temperature decreases with altitude. So when you looked at something like highlands, you could look at the high country around here. It's basically the same climate zone as the rest of Colorado, but because it is such a high altitude, you're going to have cooler temperatures, cooler temps because of the altitude. So those are the 6 zones. You can use the information in this lesson to work on your booklet, remembering, of course, that you need more information than is here. The textbook would be helpful. Pictures, either drawn or cut and pasted, would be wonderful. And feel free to be creative and use a sense of humor.